we need to prove that all square numbers end in either 0, 1, 4, 5, 6 or 9. Clearly we can't check every single possible square number, but we are going to use a proof by exhaustion by first of all identifying the cases. So let's begin by thinking that all integers can be written in the form (10k plus n), where k and n are both integers and n is between 0 and 9. So dot 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 there. Once we're happy that every integer can be written in that form, we can think about what happens when we square that. 10k plus n squared is equal to 100k squared plus 20k plus n squared. But that is 10 lots of 10k squared plus 2k plus n squared. And what this means is that any square number is some multiple of 10 plus n squared. Now, because any multiple of 10 ends in the digit 0, the final digit of this number is the final digit of n squared, because this part here is going to end in a 0, so the units part of n squared is the only non-zero units part. Let's write that down. So now we only need to consider what happens with n squared. Well, n can only take 10 possible options, so we only have to consider those 10 possible options. When n is equal to 0, n squared is equal to 0, and the last digit is 0. When n is equal to 1, n squared is equal to 1, so the last digit is 1. When n is equal to 2, n squared is equal to 4. When n is equal to 3, n squared is equal to 9. When n is equal to 4, n squared is equal to 16, which means the last digit is 6. When n is equal to 5, n squared is equal to 25, which means the last digit is equal to 5. When n is equal to 6, n squared is equal to 36, which means the last digit is 6. When n is equal to 7, n squared is equal to 49, and the last digit is 9. When n is equal to 8, n squared is equal to 64, and so the last digit is equal to 4. And finally, when n is equal to 9, n squared is equal to 81, and so the last digit is equal to 1. We've checked all possible cases for n, and all of them end in either 0, 1, 4, 9, 6 or 5. So we have shown for all possible cases the last digit of a square number is one of 0, 1, 4, 9, 6 or 5. And we've proven what we were asked to prove in the beginning.